Well, hi guys, this has been Bush. This has also been Bush, and ironically, this is what I look like. I'm not angry, this is the way my face just looks. And like most people, I had to figure out what was I going to share with y'all today. So I went to your website and looked around a little bit, looked at the research, I looked at your services, your manufacturing, and I decided that maybe if I would go back to where I started. I got to work for a company called MMI Outdoor. They did military equipment primarily, and my job was to take this tent and see if I could get it off the ground and give a little more comfort to the warfighter. So I looked at the pack size and the typical weight they would have to carry around, and it came down to the constraints: the weight, the elevation, and pack size. So I went into the sketching phase and try to understand those concepts a little bit more. And I've had a good idea of what I was going to go after. I mocked it up in 3 dimensions so I could figure out some of the functionality and geometry, and then made a prototype, and then pitched that prototype to their board of investors. The next project had to deal with Riot Gear and rethinking the bulletproof vest. That way it could take just not one shot and be done, but have more of a modular build. I got the opportunity during grad school to work on an ornithopter between Ball State and our engineering department, and it really was an exploration in combining 3D print and some fiberglassing to give a robust but form-fitting shell that could, simulate what an extra large cardinal might look like. My love for sports and sports equipment quickly found its way during undergrad to help me develop what a re-envisioned ankle brace might look like, and that quickly turned into other investigations. I started asking myself, could I make a shin guard, lightweight, very breathable, that I could make in-house? Started off as a project that was exploration of curves that turned into surfacing, and then more complex modeling, trying to understand what spatial qualities I could apply to a shin guard. 3D scanned my leg to give myself constant reference points, and then I was sure the size would fit. I went ahead and 3D printed it, cleaned it up a little bit, then put my DIY hat on using Lego and children's modeling clay. Later on, and as you can see, you can never underestimate what you can do with a set of Legos and some silicone. And I really do enjoy the end result. It's light, super breathable. The only thing I would like to improve, and instead of doing like a resin cast, I would like to have it more of a polypropylene injection molded, just to give it more rigidity and stability when it gets flexed or kicked. I did some work for a track and field coach, exploring this idea of making a trainer where the forefoot of the balls of your feet were lower friction, so give you a higher rotational speed, but then you get additional grip and touch as you transition that weight to the tips of your toes. It definitely had a learning curve, and I don't think it's something you could actually use in competition. I played around with some traditional fiberglassing. I had a summer course where we had students design and build their own kayaks. For a class outcome, I would definitely do that again. This past year, I worked with Dr. Paul Hawley over in building science with a senior student, and we're trying to identify how can you contain like the washout, the concrete slurry that comes out of a mixing truck. And so we went through all these ideas and made prototypes. And while it was successful and does have more human factors accommodations, we kept on coming back to the idea if we could remove the water from the concrete, it'd just be a lot easier to move, lighter weight. So if you got some advice on this one, man, hit me up. So let's talk about side ramblings. What other things am I into? I do like 3D printing. It stems out of 3D modeling. So I've made different types of coffee cups using this spatial geometry pattern. I do my own share of castings, and sometimes they turn out good, and then sometimes they turn out quite ugly. It's fail quickly, fail early, fail often. You learn lots. I also have an affinity for geometry. I'm not a math nerd, but I like figuring out how things go together. And so I've been teaching myself a program called Grasshopper, which lets you do parametrically driven algorithms. And those algorithms give you geometries that you can either 3D print or model for other uses. I like this idea of turning Wallace Hall into the Willy Wonka of Auburn University. So we took inspiration from these low poly birds and put them into a program called Pepicura, which takes a 3D model and lays it flat so you can print it and reassemble it. So now we brought the outside in, and it's endearing. What else? What else? Well, though I'm not there in the flesh, if you haven't met me, you've seen my work. We were given a 2,000-pound green silk loom, and we knew it was going to go into Gavin Center, so we decided if we were going to present it, we just want to present it as simple as cleanly as possible. It's a beautiful machine, a beautiful process. How could we represent that? The details are intricate, the workings are self-explanatory, and it was our honor to restore value to this object, and we hope y'all really enjoy it.